problems with chemical equations and word equations. So in the previous video, we looked at your notes and reviewed what a word equation is and what a chemical equation is. Word equation using words, chemical equation using the element symbols and the formulas, and you can also represent the states of the element and the compounds. So again, we call this one a skeleton equation because it was not balanced. There wasn't the correct number of atoms on both sides. But right now, we're not going to worry about that. We're just going to worry about writing word equations and skeleton equations. Those are our first main steps. So just to recap here, we had two things coming together to make one. So we had sodium and chlorine reacting to produce sodium chloride. So two things making one. If you review your grade 10 notes and you look in your textbook, you could probably identify this reaction as being a synthesis reaction when A plus B come together to make AB. So they make one product. So we're going to go through this package, do a few practice problems together just so you get the sense of what's going on and how to do these word equations and skeleton equations, how to classify them appropriately, as that'll be a major focus in the grade 11 unit, in this grade 11 unit. So let's go to this example here. An iron nail is put in a solution of silver nitrate, iron 2 nitrate, and silver nitrate, and silver are formed. So in this situation here, we have an iron nail. Now we're not going to write down iron nail. We're just going to write down iron. Okay. And I'm putting iron as my reactant because that's what we're starting off with. An iron nail is put into a solution of silver nitrate. And then at the end, we tell you here that these two things over here, iron 2 nitrate and silver, are formed. So if these ones are formed, those are our products. And then the ones over here must be our reactants. So iron plus silver nitrate. And they're going to produce, so I'm going to put my arrow, so they're reacting to produce iron 2 nitrate and silver plus silver. Make sure you put plus. A lot of students like to put and here, and that's wrong. You're writing down an equation. You don't want to put those additional words. The only things represented in words will be your actual reactants and your actual products, nothing else. You're going to put your plus in your arrows otherwise. Over here, don't put an equal, put arrow. Oh, down my arrow won't work. Let's try that again. There. So now we're going to convert that into a skeleton chemical equation. So we're going to represent the reactants and products using their symbols. So we have an iron nail, and an iron nail is most likely solid. So and write that S there as a subscript. It's reacting with a solution of silver nitrate. So AgNO3, and figured that out using my crisscross method. And since it's a solution, we're going to put aqueous. When you see the word solution, that means an aqueous solution, meaning it's dissolved in water. So you put AQ. You wouldn't put that in the word equation. You'd put that in the skeleton equation. And it produces iron 2 nitrate and silver. Now, in this case, we didn't provide what the states were in the descriptions. But in these type of reactions, usually what happens is the metal that's produced will be in its solid form as a precipitate, and we'll learn more about that later on. We also saw that we had some iron 2 nitrate produced, and I figure that formula out using my crisscross method or my charge balancing method. And typically in these reactions, the other compound that's produced, at least in this type of reaction, is going to be aqueous as well, so in solution. So notice here how we had our word equation with the reactants and products represented as words, and then our skeleton chemical equation with the reactants represented as their symbols and formulas. And I figured out the symbols and formulas using the crisscross method or simply my periodic table. And then my states were given to me in the reaction. And if you go back and review your notes, you should be able to see that this is a single displacement reaction. So if you look here, the iron kicked the silver out. Now the silver is alone, the silver is single, and the iron is now in a compound of its own. So we would call that a single displacement reaction. Let's go and try this one over here. Students have trouble with this one because they don't know how to identify the reactants appropriately. So if you look over here, we have C2H5OH is burned. And then we see the products here, carbon monoxide, carbon dioxide, and water vapor are produced. So our first reactant, most students can get this, is ethanol. Now, when we say that something is burned, what that means is it's actually reacting with oxygen. Whenever you burn something, it's reacting with oxygen, and that's our second reactant. It's going to produce carbon, some carbon monoxide, some carbon dioxide. So notice I'm separating every product with that plus sign, and some water. So what you can do now is you can go and write the skeleton chemical equation by putting in your formulas and your appropriate states if they're given to you. So this is a combustion reaction, specifically an incomplete combustion. And I know that because there's carbon produced and carbon monoxide. Usually when there's an incomplete combustion, the substances produced, the carbon monoxide, carbon dioxide, and water, they're going to be in their gas form because they evaporated with all the energy that was released as a result of that. And the carbon is usually in its solid form as something called soot, so just regular old carbon. That's why I'm going to put my states in, even though they weren't told to you. Let's write down our oxygen. So remember that oxygen is a Hofbrinkel element. So we have to put the 2, and then it's going to be in its gas form. So you're required to remember that. And then we could put our products down. So C plus CO2. I'm using my rules for the covalent compounds, and again, that's in its gas form. And then plus, that was CO I should have put there, sorry. So I put carbon dioxide first, and then CO. The order doesn't matter as long as you put them in with their proper formulas. And then we finally have our water that's produced. There we have a word equation and a skeleton chemical equation. And again, we know this is an incomplete combustion reaction. Notice that when I ask you for a skeleton equation, you don't have to go and balance it. You only need to go and balance it when I ask you for a balanced equation. However, I do recommend you start practicing your balancing. So after you're done your skeleton, write it separately as a balanced equation, because when we get to the third unit and we do our calculations, you're going to have to use balanced equations. Otherwise, your calculations will be incorrect. So this is an incomplete combustion reaction. There's a few other examples of combustion reactions that you can attempt here, and you'll see that it's represented in the same way, is burned. One more thing I do want to add, though, in a combustion reaction, typically energy is released, so you would write it on the reactants on the product side because energy was released. Let's try this one over here. A lot of students get this one wrong because they read it too quickly before actually writing things down. So calcium oxide and carbon dioxide are formed when calcium carbonate carbonate is heated. So not carbonated, carbonate is heated. So students usually write these two as the reactants because they're written first, but look carefully at how it's worded. Calcium oxide and carbon dioxide are formed. So since those are formed, those are your products. And so this would have to be your reactant, the calcium carbonate. So we have calcium carbonate. It's heated, and it's going to produce some calcium oxide plus some carbon dioxide. Notice I didn't put any states. I just wrote down the words. You can write down your formulas. CaCO3 heated and produces CaO plus CO2. And then you can go and put in your subscripts and your states if they're given. And as you can see, this is a decomposition reaction because one thing becomes many things.